Are we recording? Are we recording?
Yeah, we're recording. Go, go, go.
What's up, pretty people? My name is Binz, and welcome back to the Shapez BEASTMAM series. Today, we are in Chapter 4B, Episode 3. If you haven't been following along from the beginning, I would advise starting at Chapter 1, as this series is progressive and cumulative, meaning that in every video, we might build on things that were mentioned or shown in previous videos. Okay, so if this is the first video you're watching within this series, I recommend you start at video number 1 and then work your way back here. Because continuing where we left it last time, that's exactly what we're gonna do today as well. Last time, we expanded our clock to make it compatible with a variable quadrant count on the layer. We built a little module at the start right here that converts the input to a shape code, and we hooked it up to the cycler so that it knows how many steps a cycle should consist of. Now this cycler we've built so far, it is intended to iterate the amount of quadrants on a layer, but a shape can consist of up to 4 layers. So today we are gonna scale up. We are going to move from 1 layer to 4. And the way I'm going to do that, first of all, is by copying this module right here. So let's do that. And we're going to start off with just 2. There we go. Now we have an output on the first one. We have an output on the second one. And now the question is, how are we going to combine them? Because once the bottom one reaches the end of its cycle, we want it to send a pulse to the second one, and the second one should move up 1 value. And I don't know if you've noticed, but this thing is very intentional. The last value of any sequence is always white. So what we are going to do is we are going to connect a comparing unit here. We're going to set that to white. Where are my hotkeys? Come on. So we are going to check if it's white, and if it is white, we are going to emit a pulse to the next machine. Like so. Okay, so first check. Does this work? Let's send some pulses through the machine. This is green now, blue, white, and we've already have our first problem. What has happened? Well, in this case, this machine is white and it's not sending out a pulse, it's sending out a constant beam. So this top clock right here, it just started cycling through all of its values, and that's not what we want. We want it to move up 1 value. So this won't work just yet. What else can we do? Well, we could try one of these cool little edge detectors here. So let's see if this turns white, then we want a pulse to be emitted, okay? Let's try that again. Let's reset the machine. We now need to do this by means of taking away the inputs and then putting them back, like so. There we go. And now this one. Let's see if this works. So we move up, green, blue, white. And that is not what we want either, because we want this machine to switch if this one switches back to its first value, which is red. So we cannot use the rising edge detector. We need the other one, the falling edge detector. The falling edge detector means when this switches back from 1 to 0, then we are going to emit a pulse. So let's try it again. Will it work now? Green, blue, white, And perfect. This will work. That's good, right? So let's copy it 2 more times. Okay, that's more like it. And the next thing I would like to do is I'm going to bring all of these output values down so that we have something to, you know, we can see everything in one screen. So let's do that. Okay, great. And then the next thing I'm going to do is I am actually going to connect these inputs. I'm going to combine these inputs, right? So I'm going to create one input shape with more than one layer this time. And then we are going to connect that input shape to all of the clocks. All right, there we go. Now, let's disconnect this signal and connect it again and see if you spot what happens. Our first 3 values have skipped their first value in the sequence, right? Our first 3 lines have moved over to the second value in the sequence. So we really need to pay attention. What has happened? When loading up this signal, it briefly emits the last value, which is white, which is going to trigger this and already send a pulse to the next one. This is going to do the same, send to the next one, send to the next one, and that is why all of the lines, all of the outputs, except the first one, they have already moved up, so they are not in their starting position. How can we remedy that? Well, with artificial delay, tick precision. And the way we can do that is with 3 transistors. Don't ask me why it's 3. I've tested it with 4, tested it with 2, and the right amount is 3. And we need to add that up for every lane, or we need to multiply that. So 3 for this one, 6 for this one, and 9 for this one. That should work. Let's try it again, see how our initial status is going to be. That's a lot better, isn't it? And now, if we start sending pulses through the machine, we will see that everything moves up nicely. However, I don't know if you noticed this, but there is still a delay. Let's have a look at this. So we put a new pulse through the machine, and on the next state, we want this to jump to red and this to jump to white, but it's not synchronous. Look at this. So we send a pulse, this switches over to red, and now it takes 1, 2, 3, 4 ticks for this value to switch to its next state. So also here, we are going to need to compensate that with 4 ticks. And again, this is going to be cumulative. So 1, 2, 3, 4 here, and then 8 here, and 12 here. Okay, now let's try that again. We're going to cut the signal. We're going to reboot it. And now let's move up 1 tick, 2 ticks, 3 ticks, or three pulses. And now let's follow this one precisely. There it goes. Do you see this? How neatly this moves up? And boom. There we go. That is how tick synchronization needs to work in practice. Let's try some more. Let's try the third one or the fourth one. All right, let's pause the game and now follow this tick along. See this right here? Boom. All right, so now we have a tick synchronized module, right? And it works with four units on each, four quadrants on each layer, right? That's how that works. This is nice, this is neat, this is tick synchronized. So let's try it with 3 layers. Let's try it with 3 quadrants everywhere, okay? Let's see what this does. So we're going to cut the signal and load it up. Now we get green values everywhere. And let's see what happens if we move this along. Let's see what happens if we try it now. Blue, white, green. Blue, white, green. Blue, white, and now this one will switch to blue. Excellent. So that also works. Now, there is another problem because there is one scenario I haven't tested yet, and that is when the quadrant consists of, when the layer consists of 1 quadrant. Let's see what happens. There is another thing we need to do, and that is make sure the machine resets itself when we input a new shape right here. And the easiest way I could do that is if I provide a brief interruption. How can we provide that? I'm going to put a change detector right here. I'm going to connect that to a NOT gate, and then, don't ask me why, again, this is trial and error, I need an interruption of at least 2 ticks. So if we get a change of shape right here, then the signal will briefly be cut, like so, and this will effectively reset the machine. Now, what do we see? The input shape, it has 4 quadrants on its bottom layer, 3 on the second layer, 2 on the third layer, and 1 on the fourth. And this translates to a white value on this line, a blue value on this line, a green value on this line, and a red value on this line. This means that if this is our initial state, then this layer, which is the top layer of the shape, has 1 quadrant, 2 quadrants, 3 quadrants, 4 quadrants. So that checks out, okay? However, if we now start sending signals through this machine, what do we see happens? And the answer is nothing. Why doesn't anything happen? Well, the thing we set up, here's the thing. The thing we set up emits a pulse when we move away from white. And whenever we are dealing with a case where a layer consists of 1 quadrant, we are never going to move away from white because there is only 1 quadrant to check, and that one is coded with the white die. So this will never turn into a 0. So we need a solution for that. What could that solution be? Well, if you look at this rightmost line right here, then you notice only in the case where we are dealing with 1 quadrant on the layer will this initial value be white. So what can I do? I am also going to put a comparing unit right here, and I'm going to check that to white. I'm going to compare that with white. If it is white, then we are going to move we are going to connect this signal as well. Now what will happen? Well, we have a conflict. And why is that? We saw it in previous videos as well. It's because 1 and 0 are conflicting values. They are contrasting values. So the thing we need to do is we can remedy that with transistors, like for example this, so that we either get a 1 or a null value. And we also need to do that here. So let's have a look. We could do that like this. And now, since that is the case, our system will be working again. So the second layer from the bottom, it checks 2 values, the third one, or the third line. It checks 3 values, green, blue, and white. And the fourth one, finally, it checks 4 values. And all of this works exactly the way it's supposed to. Tick precise, synchronized, that's the way it is supposed to go. So now that we've done that, let's copy that to the other layers as well. And well, we don't really need it here because it is the last layer. And that's how that machine works. And you know what? I think this is good for now. This is supposed to be good. By the way, why is this happening? Oh yeah, no, this is fine. So we see these machines, they neatly send their pulses onto the next one, onto the next one, onto the next one, and that's how that works. Now, in the actual machine, right, I made it more neatly, right? I compressed it, I condensed it. You can see that everything is really close together. I made it as compact as I could, but the principle is exactly the same. So, having said that, I want to thank you for watching. I hope you found it interesting. We are yet a step closer to finding out how this machine works exactly. And if you don't want to miss out on future uploads in this series, well, then I highly recommend clicking that subscribe button, hitting the notification bell so you get those updates. And always, if you like this video, always be sure to leave a thumbs up or a nice comment on this video. That's always greatly appreciated. For today, I am signing off. See you soon, my friends. Bye.